Welcome to the internship program. I am Shubham Gupta from NextGen AI Frameworks Pvt Limited. I have 14 years of work experience in the fields of artificial intelligence, software development and robotics. This video is part 3 for image classification project using TensorFlow. Let's continue. Okay, so this is the code for compiling the model. How to do it? Model.compile, optimizer, loss function, metrics. I will tell you one by one what this means. So optimizer Adam. The Adam optimizer is used to update the weights of the model during training. Adam is an adaptive learning rate optimization algorithm that works well in practice for many problems. It is popular because it adjusts the learning rate during training, which helps the model converge faster and more effectively. So look at these words: converge faster and more effectively. So you have to use the optimizer, and the optimizer I am using here is Adam. If you want to know more about Adam, you can read in detail, but I have included one simple example to tell you what this is. The Adam optimizer is like a smart helper for teaching a model how to learn better. When the model is trying to get better at a task, Adam changes how fast or slow it learns in a way that helps it improve quickly without making mistakes. It's like adjusting the speed of your bike when going up or down hill so you can reach the finish line faster. So this is the simple way you can understand what Adam optimizer is. So this is the simple example. Now comes the loss function. Okay, so the loss function, what it means, what loss function means. As you can see, the chart is available for everything. So I will tell you step by step. So what this loss function is: the loss function tells the model how far its predictions are from the actual answers. So how far its prediction are from the actual answer, this is what being looked by the loss function. It helps the model learn during training by minimizing the difference. So it helps the model learn during training by minimizing the difference or error. This is what loss function is, and there are different types of loss functions available. What we are doing or using here is sparse categorical cross entropy. Is used for classification tasks with multiple classes. As you know, we have multiple classes, 10 classes available for different images. So we have 60,000 images in the dataset, as you know, and we are dealing with the multiple classes. So this is what you will require. And from logits true, what this means is that the model output is not passed through a softmax activation yet, so the raw output logits will be used. So let's see this simple example. Means that the model gives its answers as raw numbers not yet turned into probabilities. So it will give answers in raw numbers and not yet turned into probabilities. Later the computer will run those raw numbers into probabilities during training to help the model learn better. So remember these words: to model to learn better, you have to use this. It's like getting a rough draft before polishing it up. So this is the simplest manner you can understand this. It is like getting a rough draft before polishing it up. So this is what this is from logits true. And then of course this is easy to understand. Metrics accuracy. Accuracy is the metric we are using to evaluate how well the model is doing. It calculates the percentage of correct predictions over the total predictions. So the total predictions you have and the correct predictions, and you can look for the accuracy, how accurate it is. And I have included the accuracy metrics also, so I will tell you how to read these metrics and understand if it is going right or not. Okay, so this is how you train the model on the CIFAR 10 dataset, 10 epochs. This is how you can pass the how many times it should run or the passes. This is how you can pass. You can give the data like this. These are the passes, 10 epochs. Then for validation you can use this. So what validation means is, so there are three things. First is training data, testing data, validation data. Training data used for training the model, testing data to see if it is working fine, validation data if everything is fine or not. So three types of data are available. So here we are passing the test data in the validation. So what we are having is here the training data, here the test data, and if you remember we have split the data in two parts for checking the efficiency of the model and training the model. Okay, so 50,000 training images, 10,000 test images. We have splitted the data from the CIFAR 10 dataset here, and what here what we are doing is just putting the data through the variable here to train the model on the CIFAR 10 dataset. Then comes the part of evaluating the model. What evaluating means is test loss and test accuracy. I will show you here in a brief. Then comes the part of plotting the data for the accuracy. So this will be the plot, and I will tell you how to read this plot. Okay, so let's see. This is the chart, simple chart. So this graph shows the accuracy of a model over several training epochs represented on the x-axis, and compares the accuracy on training data, blue line labeled accuracy. So I will show you this live. Look at this chart. So each time when you run the model, it will give you some different chart. Remember this. So I will tell you according to this chart how to read this. So blue line is for accuracy, orange line with the accuracy on validation data. So one is training data, one is test data, in simple words. So epochs x-axis, each point on the x-axis represent one full pass of the training data through the model. One full pass, as you know, we have given 10 passes, 10 epochs, so it will run 10 times. So with each pass, what is happening, we are looking here. So accuracy on y-axis shows how well the model is performing with values between 0 and 1, where 1 represent 100% accuracy. So 1 is 100% accuracy, 0 is no accuracy. This is how you read the chart. This is accuracy, this is epoch. Now let us look at the key observations, what we are seeing here. So training accuracy is blue line. So blue line is training accuracy, and orange line is validation accuracy. What blue line is showing is this line steadily increases as the model improves its performance on the training data, approaching the value near 0.9 by the end of the epoch. So starting from near about 0.4 or 0.5, it will go till 0.8 to 0.9. This is what is happening. So this is for first key observation on training accuracy is this one. Second thing, okay, so second thing, this represents how well the model is performing on unseen data. So this is the training data. It already knows or have the output for that, but for the validation accuracy, the unseen data, the new data, what is the accuracy? Initially it follows the training accuracy but start flatten and even slightly decrease after few epoch. So it started to go up, then it is not validation accuracy is not increasing. So this represents how well the model performing unseen data. Initially it follows the training accuracy but starts to flatten and even slightly decrease after a few epoch. This is what is happening. Now what you will say, the model is learning and improving on both the training and validation data on the early epochs. Around around fifth epoch, the validation accuracy start to decrease slightly while the training accuracy continues to improve, indicating potential overfitting. This means the model may be learning patterns specific to the training data but not generalizing well to new unseen data. So it is working fine on training but not for the new data. So this is how you read this graph. So in summary, the model is performing well, but after a certain point it may need some regularization techniques or early stopping to avoid overfitting to the training data. So this is what it requires, but I will not apply these techniques. This is just basic example how you can uh, look for the classification problem in TensorFlow. So before telling you this second loss one, so I will close this one and I have this next chart available. So before telling about this, do you have any doubt? Okay, so let's see this chart, how to read this chart. Second graph shows the loss. So let's compare with the graph now we are having. So I told you each time when you train the model you will get a different output. Epochs on the x-axis. So epochs on x-axis and loss on y-axis, and this blue line tells about the loss, what loss are, how far off the model's prediction are. These are some technical terms here. So how you will say reading this chart, how you will read this chart. So uh, training loss is blue line. The model loss steadily decreases over time, indicating that the model is learning and getting better at minimizing the error during training. Validation loss, this initially decreases along with the training loss but starts to flatten and even rise after the few epoch. I will also show you one technique after interpretation. Okay, so both training and validation loss decrease initially, meaning the model is learning well in the beginning. Around epoch 5 the validation loss start to increase, which suggests overfitting. The model is performing well the training data. Let's see in this one also. So after 5, or let's see here 4, it starts increasing, then it goes down. So for new data it is not generalizing well. In summary, while the model is learning during training, the increasing validation loss indicates that it is starting to overfit to the training data. You might want to introduce technique like early stopping, regularization, dropout to address. So these are the techniques. I have not applied these techniques here, but just gave you the idea. If you want to improve this, I am just showing you the basic how to train this TensorFlow model. And one technique I was telling you, so let's see, I have this chart. Okay, so I have this chart and I can open snipping tool, computer, take a screenshot of this. Okay, explain. See, you will get all the details about this chart and what it means. So it will read everything from the graph and tell everything, tell the details, minute details also. So remember this, you can use the chat GPT to analyze the charts also. If you face the problem of reading the charts, you can use chat GPT. This is the complete code for the project. I have shown you, see, I have shown you how to split the data, normalize the data, class names, 10 class names are available, visualizing the 10 images of the training dataset, creating a CNN model, creating a CNN model, adding the layers like this one by one. I told you every about each and every layer, how it works. After so what these 10 classes means is output will be in the 10 classes form. So for example, horse, truck, etc., and it will print the model summary. And for the compilation part, I told you each and everything, what this means, matrices, metrics. So and then comes the part of training the model, evaluating the model, then plotting the chart. Then so this was plot training and validation accuracy over epochs, and this chart was plot training and validation loss over epochs. I have shown you both the charts, and this is the output that I am getting in the terminal. This is the output I am getting in the terminal. So I will tell you step by step how to read this. So this is the output here. Okay, so let's look at this one. The last thing is the output and logs. This is how you read it. So you will see this message 1DNN. What it means is, Deep Neural Network Library is an open source performance library for deep learning applications optimized for Intel CPUs. TensorFlow uses 1DNN to speed up certain operations on CPU, such as convolutions and matrix multiplications. So for all these tasks, 1DNN is being used. So when 1DNN optimizations are enabled, computations may follow slightly different order due to floating point arithmetic. And what floating points are, you know, decimal numbers. As a result, there might be small difference in the numerical results uh, compared to non-optimized computation. These differences are generally negligible in practical scenarios. So let's see, if you want to disable it, you can pass this. Next thing is TensorFlow optimization for CPU. So this is what it is showing. So what it means is, TensorFlow is checking for CPU features such as AV, AX2, FMA, which are CPU instructions set to accelerate deep learning tasks. So if you are running things on CPU, this will again help you for the faster processing. Then comes the part model summary. As you can see here, this is the so this is the model summary. This is how it is looking like. And I told you about all these layers. As you remember, conv 2D layer, max pooling, flat and dense layer, all these. So the max pooling 2D layer is used for convolutional neural network to reduce the size of the input data by selecting the maximum value from the small region. I told you this all earlier, so I have included this again here. Flattening to converting it to 1D vector. Then comes the dense layer, the fully connected layer, all those things. So how to read these epochs? How to read these epochs? What this means, the number of batches processed out of total number of batches. Number of batches processed, this is what it means. 19 second time taken to process all the batches for epoch, accuracy, training accuracy after the epoch. How to read this? This is 35.74% training accuracy. This is loss. How to read this? Training loss after this epoch refers to the training loss values at the end of the particular epoch. It indicates read this one. It indicates how far off the model's predictions are from the actual results. Lower values being better, so it should be less. Loss should be less in each epoch. Well accuracy, what it means is, what this one is, it is telling validation accuracy 53.47% on the test set. And well loss, what this means is, refers to the validation loss at the end of the epoch, which measures how well the model is performing on the unseen data. So which measures how well the model is performing on unseen data. This is well loss. And at last you will see the test accuracy like this. How to read this? After training the model for 10 epochs, 10 times, performance on the test set is evaluated. The test accuracy is 71.05%. Test loss on the test set is 0.8948, indicating how well the model performed. So this is the test accuracy and this is the test loss. So what you can see, look at the project, and what you can get from this is code is working as expected and the model is successfully training and validating on CIFAR 10 dataset. One DNN optimization and active, and the model achieved the test accuracy of 71.05% after 10 epoch, which is decent for a basic CNN on CIFAR 10. You can further optimize the model or experiment with deeper architecture for improved performance. So this is not the only the single way you can detect the you can do the image classification for different things. There are pre-trained model also available on the internet. This video marks the completion of image classification project using TensorFlow. I will see you in next session. Have a nice day.